expression, like is it a topicalization or a declarative or something else, or information about scope, let's say. All of that seems to be another kind of semantic information. And these seem to correspond very closely, and I suspect if we knew enough would correspond exactly to external merge for argument structure and internal merge for everything else. So to the extent that that turns out to be correct, it gives more reason to suppose that we're on the right track. Another desideratum for a well-designed system would be that it stipulate no levels of representation, no significant subsystems, except for the two interfaces, which presumably have to be there, although even that can be questioned. But at least the semantic and sensory motor interface, let's assume, are there. And in a well-designed system, there shouldn't be any others. Work of the 1990s pretty well showed, I think, that you can dispense with the descendants of what used to be called deep structure and surface structure. Not only dispense with them, but you do better by eliminating them if you keep to the simplest possible compositional function, namely merge. That leaves one level. It's the level which is the result of the application of all syntactic operations. It's the output of those and the input of the operations that map to the semantic interface. Now, that was, at the time, that was called LF. Terminologies become confused. LF is the phrase, the term LF, technical term LF, is now often used for the semantic interface, so you need some other name for what used to be called LF. But terminology apart, which at most introduces some confusion, there was these efforts to get rid of any residue of surface and deep structure did leave the level which has the properties I mentioned, properties of LF in the old sense. You can get rid of that too if you develop a specific version of principles that have appeared repeatedly in the structure of in the investigation of the structure of language since the 1950s, and in fact are all over traditional grammar too in some other form, namely principles of compositionality. So if you give a certain version of the properties of compositionality, or in more recent terms of cyclicity or strict cyclicity, then you can get rid of LF as well. The way to do it seems to be to suppose, and again this is computationally makes plenty of sense, that instead of the entire syntactic object being transferred to the two interfaces in a one-shot deal, it's transferred to the interfaces as it's constructed. So as some piece of the syntactic object is constructed, it's transferred over to the semantic and phonetic, it's not really phonetic, sensory motor interface, and it's there interpreted, and you're not allowed to modify the interpretation by any subsequent syntactic operations. So it'll stay the way it is, which of course is a huge computational saving. It means, especially on the phonological, morphological side. So you don't have to go through these operations over and over again because it's going to be stable. If you look at it closely, I'm getting beyond what I can try to explain non-technically, but let's call these units that are transferred over phases, okay? Turns out there's very good reason to believe that it's the interior of the phase that's transferred, not the whole phase. Good reasons for that, which I won't go into. The reason basically is that everything out of the interior can move on, as we know, by internal move. There's pretty good reason to believe that there are two fundamental kinds of phases, maybe only two, but at least two. One is basically verbal, headed by some functional category that says I'm a verbal phase, and another clausal, headed by a functional category that says I'm a clausal phase. Now, these are usually called C and V, naturally. And there's pretty good reason to believe that they exist. What appears to be the case is that in the design properties are such that at these two phases, the interior of the phase is handed over to the sensory motor and the semantic system, and they're interpreted, and there's no further access to their interior. It can't be modified by any further syntactic operation. Now, that enormously reduces complication, and it has other important consequences. I mentioned before that in a sentence like, say, what John saw what, or for that matter, John saw John, we have to be able to know somehow whether the thing that appears twice was created by internal merge or external merge. Because of the duality of semantics, going to have a different interpretation depending on which it is. Well, that information is available at the phase level. In fact, exactly these two phase levels, at the verbal phase and the clausal phase, that information is available. But at any other position in the computation, it's just not available. It takes a little work to show it, but you can. So if there's going to be a correct identification of copies, so you'll know that John saw John is okay, but it means two different Johns. If there's going to be a correct interpretation of the copies, then it seems that for that reason alone, you need these two phases. Same turns out to be true for features that don't have any intrinsic semantic properties, what are called uninterpretable features, like, say, nominative versus accusative case, or plural or singular agreement on a verb, actually on the inflectional element that the verb attaches to. These don't have any intrinsic meaning. They just have a value depending on the structure in which they appear. That information is also available at the phase level, not before and not after, which supports, again, from another point of view, the conclusion that it's precisely at this level that transfer takes place. And there are other things of that nature. So I think there's a fair amount of evidence that not only that computation goes phase by phase, meeting sensible computational principles, but that these are, in fact, the phases. And that can plausibly be thought of as a consequence of the strong minimalist thesis. If language is going to be perfectly designed, it looks as if that's the way it ought to work. Now, I don't want to say that incidentally, this does not mean, this has been misinterpreted, so let me stress it. It does not mean that there is no further access anywhere in language use to the internal parts of the computation. That can't be true. In using language, in speaking or interpreting, at the very least, you bring together the semantic and the sensory motor expressions, which are generated separately, but use both of them, of course. So there must be some kind of homunculus sitting there which has access to everything that's going on, and in fact a lot more, because in language use you're not restricted to what you hear, of course. It's easy to show that people interpret what they hear on the basis of expectations and background assumptions, and overrides the phonetics of what they hear very often, and so on. So yes, there's a homunculus who's using everything, and it's a reasonable proposal is that what appear to be global properties of expressions, either phonetic or semantic, could well belong to the component of the whole system of human thought and action that involves the homunculus, bringing everything together, including both the semantic and phonetic side. And there are other further problems. They're each an optimal principle of computational efficiency. Am I going on too long? I lost track. A couple of minutes. Yeah. An optimal principle of computational efficiency would be that the information about that when you have a syntactic object, any information about it that's relevant to further computation ought to be very easily and quickly identifiable by algorithm, by some optimal algorithm. And what that means is that all the information should be in a particular lexical item that was the basis for the construction of it, what's projected in old phrase structure theories. In the case of the verbal phase and the clausal phase, all relevant information should be in the V and the C. And that turns out to be true. Like what's relevant in a verb phrase for further computation is the kind of verb it is, and not, say, the kind of object it has, or prepositional phrase that's in there, and so on. So we have, that property seems well established, what are called the heads of the phases, which are incidentally very easily determinable by algorithm, and where they're not, you can show interesting problems. The heads carry all the information, and those are the things that are identified. Well, without going on with this, there are plenty of problems which I won't go into, but if you want a good summary of them, there's a good paper by, in the last issue of Syntax, Journal Syntax, by Bex and Groman, which gives a whole pile of problems. Most of them, I think, can be handled properly, but there are some that clearly remain as topics for further inquiry. I'll assume that this is more or less correct and just make a few more comments about it. Well, as I said before, it's extremely easy to find problems in the infinitely many problems whenever you look at linguistic or apparently linguistic phenomena. And you then have two approaches that you can take. One is to develop some technology to characterize the problem, to describe it, and what's sometimes called giving a solution, but it's really giving a kind of redescription, which may be a valuable step towards organizing the material for further inquiry. And maybe that's as far as you can go. Well, if that's as far as you can go, then the technology has to be attributed to universal grammar, part of the genetic component, and the language is more of a mess than we hoped. Huge problem for any study of evolution of language, if anything like that never comes along. The other possibility would be to try to chip away at it and see if you can get a principled explanation for at least part of it. And often that's possible in moving towards SMT. Well, let me just finish by illustrating what I have in mind with one particular problem. Actually, it's an old saw, and thinking about how you might move towards a principled explanation for it. The old saw is what's called ECP in linguistic terminology. So if you have a sentence like, he wondered who saw what, you can turn it into from a declarative to an interrogative by moving either who or what to the edge of the sentence, giving the proper scope, and making sure that something appears after wonder to give proper scope for the internal question. So you can get either the sentence, what did he wonder who saw, or who did he wonder what saw? Well, the first one is not a bad sentence. It's a little deviant, but I think for irrelevant reasons. The second one, what did he determine who saw, is total gibberish. Who did he wonder what saw is complete gibberish. And it's not obvious why that should be true. I mean, one seems as easy to do as the other, but it's a very solid principle, a solid observation, and holds in many other cases. Well, as far as I'm aware, there's only one proposal around in the literature that seems to have anything serious to say about that. It's called the vacuous movement hypothesis, about 20 years ago. It's based on an observation, namely that in who saw what, or I wonder who saw what, there's no overt evidence that the who has actually moved to the scopal position. You don't hear it, you know. And then you could propose a principle which says, well, if you don't hear it, you don't move it, at least overtly. It still has to be moved covertly somehow to give you the scopal interpretation. So that's the vacuous movement hypothesis, and it pretty much covers the data. There are two problems with it, however. One is that it's a new principle. It's stipulated. No particular reason why it should be true. You know, just makes as much sense for the opposite to be true. The other problem, that leaves one level. It's the level which is the result of the application of all syntactic operations. It's the output of those and the input of the operations that map to the semantic interface. Now, that was, at the time, that was called LF. No significant subsystems, except for the two interfaces, which presumably have to be there, although even that can be questioned. But at least the semantic and sensory motor interface, let's assume, are there. And in a well-designed system, there shouldn't be any others. Work of the 1990s, expression, like is it a topicalization or a declarative or something else, or information about scope, let's say. All of that seems to be another kind of semantic information. And these seem to correspond very closely, and I suspect if we knew enough would correspond exactly to external merge for argument structure. Pretty well showed, I think, that you can dispense with the descendants of what used to be called deep structure and surface structure. Not only dispense with them, but you do better by eliminating them if you keep to the simplest possible compositional function, namely merge. And internal merge for everything else. So to the extent that that turns out to be correct, it gives more reason to suppose that we're on the right track. Another desideratum for a well-designed system would be that it stipulate no levels of representation